By now, Tailscale is no secret. I've been using it for a year or two, and it's been a total game changer for how I interact with my networks. Gone are the days of generating my own WireGuard keys, finding a good way to keep them in sync across all my devices, and whilst I do fully acknowledge that there are some downsides in having someone else host my WireGuard keys for me, it's a trade-off in terms of convenience that I'm willing to make. The biggest compliment I can give to Tailscale is that it just works. Now, as self-hosters, we've been trying to find ways to solve the problem of accessing our services from anywhere in the world without opening up ports in our firewalls since basically the beginning of time. That is the promise of Tailscale. In today's video, we're going to take a deep dive into the world of DNS, specifically looking at Tailscale's MagicDNS feature. This allows us to do neat things like refer to our Tailnet devices by name or configure SplitDNS to query remote DNS servers. I'll explain what all of that means in a minute and show you how to get it set up. In order to visualize this, let's imagine that we have a remote network, and in that network, we want to host some services. Perhaps this is at a parent's house or a friend's house or something like that. Now, we don't want to expose these services to the internet, but we do want to be able to access them via a fully qualified domain name in our browser. So something like myservice.mumshouse.domain.com. We also want our parent to be able to access this service in their local network, even if they're not using Tailscale at all. We're going to do all this using SplitDNS. And in order for this whole SplitDNS thing to actually be properly useful, we're going to need a local DNS server in the remote network, and ideally some level of control over the DHCP in the remote network's firewall or router, and that's to ensure that clients there get leases configured with our DNS server and not some ISP automatically generated garbage. We're also going to need a way to run a subnet router in the remote network. In my case, if it's at all possible, I will run this on the OPNsense firewall. Now, if that isn't an option, I'll try and carve out a VM somewhere. And if that's not an option, I'll find something like a Raspberry Pi or a really small low power device I can just throw in the corner and install Tailscale on that. Now, we could throw all this in a public DNS provider, but that feels unnecessarily inefficient given that Tailscale's local DNS implementation with MagicDNS caches all of these responses locally. If the request is a name found in your Tailnet, that request never leaves your device. That's because Tailscale runs a local DNS server on every single Tailscale client. Yes, that includes your phone. I think that's pretty cool. One final thing before we get into a real example is it's really, really, really important for your own sanity that the subnet ranges of all of these different networks in question do not overlap. Pick something unique for each site and it's going to make your life a whole lot easier. I find postal codes or house numbers or phone numbers or whatever helpful in IP ranges as a unique-ish identifier in either the second or third octet. I hope you're still visualizing that remote network because now I've decided that I want to deploy Nextcloud both here at home and also at my parents' house. To keep things simple for all of us, let's come up with a standardized naming scheme so that it's obvious what's going to be running where. I typically like to lay out my DNS something like this: service.host.site.domain.com. And so a real-world example of this might be nextcloud.dell3060.ncusa.badgersbits.io or nextcloud.synology.lancashire.uk.badgersbits.io, and so on. Using this method, we're able to tell what service is running on which box and then which physical site that box is located in. Now when we make these requests, Tailscale knows, thanks to the configuration we've done in our admin panel, to forward any requests for Lancs UK to that local DNS server in the remote network. Note that the matching is done at the site level and not at the service or host level. We could get into doing that, but it would get quite messy quite quickly, as having one entry per service in our DNS server, that's a lot to manage. Wildcards make this really easy for us, and it's why I recommend a 5-layer deep domain name system. Now, this whole process is SplitDNS in action. The process of sending requests to different places based on matching the contents of a portion of a URL. So let's jump over to my workstation and take a quick look at my Tailscale dashboard to see how we configure this. So this is a brand new Tailnet that I've created just for the purposes of this video. I'm logged into my Tailscale admin dashboard right here. And what I wanted to show you is that currently there's only one device connected, and that's this laptop that we're using to do this recording. I've built a remote demo site. I've built this in a VLAN on my local network using Proxmox. So I've got three systems. I've got OPNsense running as a fake virtual firewall. I've got Pi-hole running as a fake virtual DNS system. And then I've got Ubuntu running as a fake application server. And those three nodes are going to be the three that we're going to use throughout this demo. The fact that they're in a VLAN isn't important and it's not relevant to Tailscale whatsoever, but I thought I'd just explain it so that you knew what was going on. Now, what we're going to want to do is just take a quick look at what we can't do first of all. So if we go and try and connect to one of these nodes, this is from my local laptop. I'm trying to connect to 192.168.150.1. Anything with that 150 in the subnet octet, the third octet, we can just pretend, for sake of argument, is in a different building, in a different continent, somewhere that we don't actually have physical access to right now. So the first thing that we want to do is find a way to install Tailscale in that remote subnet so that we can at least connect to one of these hosts. I'm going to bring in the Ubuntu VM that I talked about at the beginning of this video. This is going to act as a way for me to Trojan into the network, the remote network, temporarily. Now you could use TeamViewer onto a family member's laptop, or actually go and visit them if you want to, and go and connect physically to the command line of OPNsense itself. One thing I wanted to show you before we install Tailscale is that this network is actually running a bunch of other applications just fine. So, it's got DNS running in Pi-hole. We've got LibreSpeed running and applications as well. So if Tailscale isn't even involved in the equation, everything's still working just fine. And that's really important, because the last thing we want is, a support call from a family member saying, hey, things are broken. Can you come fix it for me? When it's some complicated thing that you've configured that's got a upstream dependency that you can't figure out remotely. Now, the easiest way to show you how to install Tailscale is to actually drop to the command line. You can't install Tailscale through the GUI. So we need to SSH into Tailscale, or hook up a keyboard, a monitor, and a mouse if you're physically visiting family. Select option 8 to go to a shell. Now, the next thing we're going to want to do is this option here of fetch a memugmail.conf file. There'll be a link to this in the description down below, by the way. In fact, I'm going to be writing a blog post about this entire process, so check out that blog post link for all of this kind of documentation. We've installed the memugmail repo configuration file. You're probably familiar with this kind of stuff if you've used Linux. It's like installing an apt repo or something like that. Package update is analogous to running apt update in Ubuntu, for example. And the next thing we're going to want to do is a package install Tailscale once we've done the package update. PKG is just BSD's equivalent of apt, for example. Now, we are going to want to install that 25 megabyte package. Yes, please. Once that's done, we're going to want to do a couple of things with the Tailscale D service, the Tailscale daemon. We're going to want firstly to enable it so that this daemon starts when Tailscale boots. And secondly, we're going to start it manually so that we can actually use it right away. Now, what we can do next, let's just check the status of it, make sure that that all worked fine. Yes, running as PID 61422. Now it's time to actually start using Tailscale. So the first command that we always want to run when adding a new node to our Tailnet is Tailscale up. Now I'm going to add one more option to this of advertise routes. And what this is going to do, if I do 192.168.150.0/24, is it's going to allow any device connected to our Tailnet access to any device in this 150.0/24 subnet. So all of the 254 devices that get IP addresses from this particular DHCP server, those are going to get access from the Tailnet. Now, when I hit enter, it's going to ask me to log in at the Tailscale web interface. So I'm going to go back over to a browser, log into my Tailscale interface using whatever authentication method you've picked. And under here, it's going to give me a bunch of information about the specific node that we're trying to add. We can see, do we want to connect the device OPNsense to your Tailnet? Yes, please. Let's click connect. And you say you approved OPNsense. Excellent. Give it a second and it will refresh. And we can see right away that we've now added OPNsense into our Tailnet. It's got its own private IP address. But there's an option here, subnets, with an exclamation mark next to it. And this is because by default, Tailscale, we've advertised the root 150.0, but by default, it's a fairly insecure thing to, if someone got malicious access to your physical hardware and they wanted to enable subnet routing, but they didn't have, for some reason, access to your Tailnet dashboard, your admin console, they couldn't get island hopping going in that way without also having access to your Tailscale dashboard. So if I select this checkbox here and turn it on, that now means I can connect to any device through my Tailnet subnet router, which is running on OPNsense in this subnet. Now I know I only just turned it on, but I'm going to turn it off again just very briefly, just to show you that I can't actually connect to anything right now on this 150.subnet. So if I just do ping 192.168.150.1, we can see that currently I have no route to host. And if I check this box here and go back to my terminal window, we can see in real time that's now updated underneath. And also I can actually access OPNsense from my local laptop, which isn't in that remote location, remember, from a browser. So that's great. We've enabled a Tailscale subnet router, and we have now connected to it from our remote laptop. The next thing to do is to start work on DNS. So if we go to OPNsense.demosite1, DNS.demosite speed, none of this stuff is working. And let's take a quick look at what happens. So if we try to go to OPNsense.demosite1.badgersbit.io, we get some interesting information. So I'm using a tool here called Dig. This is a DNS querying tool. And we can see it. We're going through the Tailscale DNS server at quad 100, but we're not getting any reply whatsoever. We'd normally expect to see, let me just show you something here, google.com. We'd normally expect to see the answer section full of IP addresses that have translated google.com into a bunch of different IP addresses. But with OPNsense right now, we're not getting anything at all, and that's a problem. In order to solve that problem, we're going to need to head over to the Tailscale admin dashboard and configure some DNS settings. So if we take a quick look over here, we are familiar with this page. We just added our OPNsense node to it. And under Machines, Services, Users, Access Control, and Logs, there's another option here called DNS. Now, under this page, we've got a bunch of information. So we've got our unique Tailnet name, 70b8b.ts.net. We want to leave MagicDNS enabled. But you can see by default, the quad 100 MagicDNS IP address that's here is kind of a reserved one. It's part of the carrier grade NAT IP block. So this IP address doesn't actually get routed to the public internet. Now, if we want to add something that's going to enable Demosite 1 to actually resolve, we're going to need to do a couple of things. First of all, we're going to need to enable Cloudflare public DNS. This is so that we can force our clients to have their local DNS overridden. I like to do this because it means that when I connect to a specific Tailnet, it means I'm switching contexts mentally, but also switching context with DNS as well. By enabling Cloudflare as my public DNS, I guarantee that all of the clients connected to my Tailnet are all using Cloudflare for their public DNS. That's useful for me because that's where I host all of my self-hosted kind of DNS entries for all of my records. So propagation is going to be the fastest for me through Cloudflare. Now, the next thing that we need to do is click on Add Name Server and then go to Custom. And this is where the entire premise of this video will become, hopefully, a bit more clear to you. So what we're going to do is add in a 192.168.150.2. And .2 is my Pi-hole instance, which is running in the remote network. But we're going to want to check this box here that says Split DNS, restricted domain, Split DNS. And we're going to want to enable that for every DNS query which matches badgersbits.io or demosite1.badgersbits.io. When I click save, this is going to take a second to update on all of the clients. But what we should see when we go back to my terminal window is it should update now and give us an IP address back. There we go. In real time, that worked perfectly. Now, what this is actually doing under the hood is it's routing everything that matches demosite1.badgersbits.io as a wildcard to my caddy reverse proxy, which is running in the remote subnet. So if I go back to this tab over here, we can see that now I can access OPNsense with a proper TLS certificate running in the remote LAN, all locally. This is not available to the public internet. None of this is exposed publicly. This is all happening over Tailscale. Same is true of my DNS server. So this is running at dns.demosite1.badgersbits. And the same is true of the LibreSpeed instance as well. I mean, the speed's going to be horrible because it's going over a tethered 5G connection. But that's not what we're testing today. If you want to see speed tests, that was my last video. What we're proving here is that I can now access these websites as if I was in that physical LAN, even though I'm not. And the reason we're able to do that is because of wildcards. I'm going to show you how you configure a wildcard in Pi-hole. This is a Pi-hole specific thing, but it's actually using DNS mask under the hood. And so if we look at this file here, 03/custom, this is in /etc/dnsmask.d, and I'm connected as root to my LXC container that's hosting Pi-hole for me. We can see here that I have this line, which is address equals /demosite1.badgersbits.io /192.168.150.10. And the reason that's important is because if I wanted to query the DNS for a specific domain, I know there's a lot of windows, so just hang on, we'll make it work. We can see here that OPNsense isn't actually configured as a specific host in any DNS entries anywhere. And I can prove that to you, but I can literally just type in a random string of utter nonsense 15 levels deep, and I'll still get the same IP address back. That's the power of wildcard DNS matching. Now, if I wanted to add another one, let's say, for example, I wanted to add a new host to my network of Batman for whatever reason, and I wanted to give that an IP address of 150.99, I'd go in and I'd modify my custom conf file in Pi-hole under the hood, add this wildcard domain in here, and then restart the Pi-hole DNS engine. What I then need to do is ask Dig and say, hey, if I wanted to go to, I don't know, robin.batman.demosite1.badgersbits.io, where can I find that particular service? And you can see it's returned based on the wildcard template matching. It's returned 150.99 for that particular DNS entry. Now, on occasion, you might find a situation where you want to completely ignore your reverse proxy and completely ignore all of the wildcards that are in here and override specific things. We can do that really easily. If we go to Pi-hole, remember this is the DNS for the entire network. So we can go to local DNS and then DNS records in here. And you see I've actually got one for Pi-hole itself, so it's not dependent on any third-party service. Maybe you'd find that useful for OPNsense as well. So we could do, I don't know, router.demosite1. Well, let's do firewall. It's technically a firewall, so let's do that. Firewall.demosite1.badgersbits.io. We go to 192.168.150.1. And if we click add and then go back to the terminal and we type in firewall, we'll see that we get our 150.1 come back. Now, I do have a full blog post on a fully automated DNS setup using Ansible and Pi-hole in this exact manner. And I'll be doing a video on that in the future as well, but it's a lot of work. So I'll get to it, but just not yet. But But the biggest caveat really about wildcards is that you can't set them through the UI, which is the entire reason that I had to drop to the Pi-hole terminal in order to make that happen. Now, if you wanted to add more remote sites, I'm not going to do it for the video today. I think we're quite long enough already, but it'd be easy enough just to come in here and add, a non-overlapping subnet. Remember, it's really important that your subnets don't overlap. Let's just do another DNS server at 140.2, and we'll set that to demo site 2.badgersbits.io. And I think you start to get the idea of how you can add specific websites or specific physical sites and have multiple sites and access them from a single client as if it's just all one big flat network. Now, the other thing to think about too are what happens if you have non-conformist URLs. So something maybe like a specific service that you don't want to put in a local Pi-hole in a specific remote site for some reason. This could be a really old service that is just doesn't match your current naming conventions. And so let's just make one up. Let's just do 192.168.1.99. Let's just say, for whatever reason, you want your Home Assistant URL to be a really short one. So you could just do ha.badgersbits.io. That doesn't tell you anything about where it physically is or what host it's running on, but sometimes that's what you want. We can restrict it to that specific domain, and then any request you make to ha.badgersbits will go to that specific host. And in that way, you can get kind of complicated with how you configure and override these various different things if you want to. Now, recently, Tailscale made some changes to their pricing structures. They reduced the limits on the free tier for the numbers of subnet routers. They increased the number of nodes in a free Tailnet to 100. And they maintain that their business model is based around getting more technical users excited and interested in Tailscale, who then take it into work and monetize the product that way. I love this approach and applaud Tailscale for doing it. But not only doing it, but doubling down on that business model as they mature and add new features as well. From an overall solution point of view, it's worth remembering that all of these rules, I kind of made them up and they work for me, but you're totally at liberty to make up your own naming conventions, your own rules, and break them whenever you like. Whatever works for you, it's your infrastructure after all. There are thousands of different possible permutations to make a solution like this work, and I couldn't possibly cover all of them. Today's video was designed to give you an understanding for you to go away and design your own solutions based around Tailscale and SplitDNS. Let me know down in the comments what you end up building. I'd love to hear it. Also down in the description will be a link to a blog post where all of the diagrams from today's video can be found. And that's Tailscales MagicDNS in a nutshell, really. It's a super simple but very powerful way to route DNS requests around to different endpoints with no client-side configuration or complex routing table foo required. I've been Alex from KTZ Systems, and as always, thank you so much for watching.